Hello aspirant. This question is from GATE 2019 Mechanical Engineering paper set 2. It's question number 48. An idealized centrifugal pump, blade outer radius of 50 mm, consumes 2 kilowatt power while running at 3000 rpm. The entry of the fluid into the pump is axial and the exit from the pump is radial with respect to the impeller. If the losses are neglected, then the mass flow rate of the liquid through the pump is dash kg per second. Let's discuss the given things. So the first thing that is given is the pump is a idealized centrifugal pump. CP is short for centrifugal pump. And the features of these idealized pumps, here itself they have given that the entry of flow is axial and the exit is radial. So they want to tell you that if this is the side view of impeller, then the flow is entering in this direction along the axis of the impeller, and that is why it is said entry is axial, while the exit of the flow is radially. That means it's along the direction of an outward perpendicular from the plane of screen. So entry of the flow and exit of the flow are not in the same plane. They are in two mutually perpendicular planes. Now as the entry of flow is axial, we do not have any component of velocity that is tangential to the impeller. And tangential component is called to be the whirl component. So whirl component at inlet, that is 1, is equal to 0. Second thing that is given, so radial exit gives us a quantification of velocity as whirl component at outlet is equal to the tangential velocity of impeller at that point. Impeller is rotating and hence it has a tangential velocity at every point, and u2 is that tangential velocity at outlet point. So these conditions we will incorporate while finding out the mass flow rate. Let's write all the given values. We have blade outer radius R2 is 50 mm. Power consumed is given to be 2 kilowatt. Speed of impeller is given to be 3000 rpm. And it's also mentioned that the losses are 0. Now let's see what is the significance of the power value that is given. An impeller is a machine that imparts energy to water so that it can be pumped to a desired height. And to impart that energy, power is supplied to the impeller so that it can rotate with an angular velocity omega. So we can write power consumed, which is 2 kilowatt. So that power consumed is equal to the power developed. Now what is this power developed? This power developed is nothing but the rate of energy transferred to the water so that water can be pumped to a desired height. And this equality is established because losses are given to be 0. So whatever is supplied is completely utilized because losses are 0. Now we can write power developed, let that be PD, short for power developed, is equal to, impeller is a rotating machine. So in rotational motion, we have power to be equal to torque generated into the angular velocity of impeller. Now this torque generated is nothing but the change in angular momentum. So we can write final angular momentum, that is at outlet, minus initial angular momentum, which was at inlet, into omega. Just taking m dot common from both these terms and multiplying omega inside, we have m dot into VW2 R2 omega minus VW1 R1 omega. We can substitute VW1 to be 0 here. We know R2 omega and R1 omega are nothing but tangential velocities of impeller at outlet and at inlet. Also VW2 was equal to U2 as per the axial entry of flow and radial exit of flow. Hence we have power developed is equal to m dot u2 square. Now as the outlet radius is given to us to be 50 mm, we can calculate u2. u2 is nothing but r2 omega, which is equal to r2 2 pi n by 60. We have u2 as 15.707 meter per second. Just rearranging this equation, we get m dot, that is mass flow rate, is equal to power developed divided by u2 square. Putting the values, power developed is equal to power consumed, which is 2000 watt, divided by u2 is 15.707 square. We have to use all the values in SI unit. So mass flow rate is equal to 8.1067 kg per second. So we have our answer as 8.1067. It is to be rounded off to 2 decimal places. So we can write the answer 8.11 kg per second. For detailed information on this topic, you can refer to the NPTEL video Module 1 Lecture 21 Centrifugal Compressor Part 1, in which the velocity diagrams, the flow through impeller and the energy transferred by the impeller to the water is very elaborately explained. This video is from the course Introduction to Fluid Mechanics and Compressible Flow by Professor S.K. Som, Department of Mechanical Engineering, IIT Kharagpur. I hope you understood this solution. Thank you.